little bit of a rainy morning here in Austin, so hope the weather is better where you are calling in from. Happy to present the fifth Tech Talk session. And like Brett said, we're going into the metadata deep dive part 2, finishing up what Jim started last week. All right, so a little bit about me. I'm from Dell as well, so I worked on this project when it was still called Fuse. I wrote a bunch of the Southside services, a bunch of the device services, and the device service SDK. Just for those of you who couldn't call in last week because the time didn't work out, quick recap on the London meetings from 2 weeks ago. The technical committee met up there in person. We established our MVP tasks and to-dos for the Barcelona release for October 3rd through 5th. All this is out there on the roadmap on the wiki. So please take a look at that when you get a chance. Let us know if you have any other ideas or contributions to add.
Oh, Tyler, just to chime in real quick, I think, I believe you actually had a slide that had shown your image and a little more about you. Your screen is just showing us the title slide.
Oh, okay. Let me take a look at that. Oh, is it better now? Same?
Yeah, I'm still just seeing slide 1, the title slide. Is anyone else seeing advancing slides, or is it just my PC?
I'm not seeing advancing slides, Brett, just the title 1 slide.
Oh, there we go, Tyler.
Okay.
There's number 2. Perfect.
Thank you, guys. All right. So here's the Barcelona release page that I was talking about. So we have the link there to the wiki page for the roadmap. All right, our agenda for today, we're going through the device profile. We're going to talk about our commands, resources, and device resources, our 3 major components of the device profile. We'll talk about device provisioning from a metadata perspective and device provisioning from a device service perspective. And then we'll take a few minutes to go over the questions that you guys have. So just from the architecture view, we'll be talking about the metadata and device service components for today. Quick recap from last week. Jim had talked about the metadata triumvirate. So what we're focused on here is the device profile aspect of this. Jim had talked last week about the role of the device service object and the device object. So what we really want to highlight here is the device profile is how the device service handles what to expose to the rest of the system, what APIs it's supposed to provide for each of its managed devices, and how that actually plays out at the device level. Jim had mentioned last week at a high-level example, if you have a BACnet thermostat, you can have a device profile that talks about the general characteristics of that. The device profile might describe things such as how to get the temperature, how to get the humidity, and how to get or set various other parameters such as the cooling or heating point. And so we're going to take a deeper dive into this example today. Okay, so what the device profile does is it isolates some of the different layers that the device service needs to implement. So from a high-level perspective, the controller layer, which is our REST API layer today, in the future will provide implementations that support other transport protocols in between the core services and device services. But right now, the controller layer is all a REST API. So our commands defined the interface that the command service is able to call into. We have our handler layer, which says, okay, now I have a command. What does that do at the device layer? And then we have our device driver layer, which is going to be your BACnet stack or your Bluetooth stack. It's going to be protocol specific implementation. And what we have is we have our device resources, which are essentially all the parameters that you would need to be able to tell your driver how to interface with a endpoint device. So starting at the top, at the command layer, here we have an actual BACnet profile, so a segment of that on the right, and we'll talk about what these different components are. So we have, in this case, we're defining a command named setPoint, and it enables two different methods. So we have a HTTP GET method and an HTTP PUT method defined for this command. In this case, we can define different REST endpoints for each of these. So you'll notice that this is all templated for the device profile. So we can use this one device profile for multiple devices at the device service layer. So if I had 2 or 3 or 4 identical thermostats that were distributed around, we can use this profile to serve all of them. And this device ID field here gets provisioned by metadata to actually translate into the command. We define our HTTP responses that are expected. We'll either get a 200 with its OK, here's the values, or a 503, it's unavailable. Keep in mind this is the HTTP GET, so we're expecting to get back the cooling point and heating point as a result of this command. On the PUT method, we're actually writing to these values at the endpoint device. So we're going to be passing in a cooling point and a heating point to be written to the actual device. It's either going to be successful, it will be an invalid request, or we will have a service unavailable. And in each case, we will be expecting that we're not getting any values back other than a success code. Keep in mind that all of the expected values and parameter fields map to a value descriptor that has been provisioned in metadata. So that's controlling what format, min and max, and things like that. Jim had talked about value descriptors last week, and that's kind of our way of describing what a particular value's expected range is. Moving on to our resources. So these control the logical flow from commands. So a command is going to be the REST API call. A resource says, how do I handle this command? In this case, a resource supports a mapping to either a device resource, which if you remember is at the driver layer, or it can fan out and call multiple other resources. And so what we can do is we can define some inheritance here that allows us to say, okay, this command should return the temperature, but I have another one that's also going to return the temperature. So I don't want to redefine the temperature method. I'm just going to make a separate call so that each command service serves that back up. And that'll be more clear in a moment. What we also have is we have get commands and we have set commands. So these are analogous to read and write operations. In this case, going back to our command example, we have a get on the setPoint method. And so what this is actually going to do is it's going to trigger 2 separate reads, one for the cooling point and one for the heating point. And so what these are is they're references to the device resources, which we will get to in a second. One other thing I want to call out here is that this parameter right here is controlling which value descriptor we're mapping to. So if you have a different name for your device resource, you can map it to a more generic value descriptor using this parameter field. And then our put method from the previous command maps into this set routine, which is going to be doing 2 set operations to the same device resources. And now we're down to the device resources level. So this is the third of our 3 components for the profile. And so that cooling point object from the last one maps into this cooling point device resource. And so here what we have is we have attributes which define our protocol specific data. So in this case, BACnet uses types, instances, and properties. For Bluetooth, you might use UUIDs on the BLE. And other protocols will have other specific nomenclature. So what this does is it allows you to keep the nomenclature of the low-level protocol, but abstract that from the higher levels of the stack. We don't care if it's a BACnet or a SNMP device at the top layers. The device service itself should be the only one that knows about that difference. So in this case, the cooling point is going to be a BACnet analog value type. It will be the instance number 20, and it is going to be the present value property of that resource on the device. Other things to call out here, we have properties in the device resource, which define how that data is transformed or typed as it goes up the stack. These property values in the device service SDK are used to populate the value descriptors. So we pull our minimum and maximum values and our value type out of this layer. Other things, we've got our units field, which show how to make a value human readable as you go up as well. And so all of this data defined in the device resource is fed to the driver interface in addition to the device address information in order to make individual calls to the device. So as a quick note, when you're writing a device profile, I generally like to start at the device resource layer and define what I want to be exposed from the device, whether that's your humidity, temperature, cooling point, heating point in this case, or other more unique values. And then I go up to the command layer and say, how do I want the command structure to be? Do I want to have one command that gets all of these at the same time? Do I need to have multiple individual calls that are getting more fine-grained data? And then I define the resource layer in order to accommodate those commands and map them to the device resources. So as a flow example, our device service controller, so the API, receives the command set point with the parameters cooling point 75 and heating point 68, which, as we know from the device resource layer, those are in degrees Fahrenheit. The device service handler maps those to the set point resource, and it splits it into 2 device resource calls to the driver. And then the driver executes those 2 calls sequentially. So the first one is going to be setting the cooling point to 75. And so we'll have our address information for BACnet. You might have an IP address. You might have some key information about how to reach and interface with the device. And then it's going to pull the device resource information for cooling point about the type, instance, and property in order to let our BACnet driver know how to actually reach the data that we know is there. Then it will call the heating point write command, set the device heating point to 68 using the same thing. And upon a successful completion, the device service would return the 204 code as specified in the command.
Tyler, a quick question came through the chat.
Absolutely.
Can parameters support blank spaces? So example being cooling space point instead of cooling point together.
Yeah, these are all strings. That's a great question. They're just strings in our in the metadata. So absolutely. Okay. So flipping over to our device provisioning, we have kind of 2 different paradigms here. We've got our top-down model, which would be either operator or cloud-driven in a deployment situation. In this case, we're going to be relying on a management console or a UI or a system management interface, and that's going to serve as our client. I know Jim had went over this timing diagram last week, but it is important for what we're talking about today. So you'll have metadata will receive a request from whatever this operator client is to add a new device. Going back to our triumvirate, we need to make sure that our device service object exists. And we need to make sure that our device profile exists in order to create a mapping between those objects. Then metadata will insert the device into the Mongo database and get back a unique device identifier. And then it will inform the device service, hey, you've got a new device. Okay? And that's done through the callback methods, which interface with the device service APIs for adding a new device. And then it's going to tell the device or the cloud operator that, hey, you've got a new device added successfully. In our other paradigm, we've got more of a bottom-up approach in which we've got an operator supplies some provisioning rules and a device profile for how to treat any such devices it finds. But the discovery of the device candidates happens at the device service level. And so that's going to be protocol specific. And as was called out last week, there may or may not be a way to do discovery at the protocol level. Some of them will have it, some of them won't. So this is more of an option for if you have a discoverable protocol. So an example of this might be a Bluetooth scan. You might be able to do some things with discovering serially attached devices to a gateway. Or there might be a way for a device to say, hey, I'm here. Somebody come talk to me. Just as reference examples, we do have some name and MAC filtering built into the Bluetooth device service, which will be open sourcing in the near future from Dell. But you can be as, this is left up to the device service implementer, what kind of discovery method you're able to support. In any case, once you've discovered a candidate device, it matches up with your provisioning rules that are specified by your operator, then the device service is able to say, okay, I've got a device profile for this. I know the device service is me, so I have my triumvirate, so I'm going to send the device object directly to metadata, in which case our client from the last flow is the device service itself. And then these provisioning rules that I had talked about are specified in our provision watcher object, which essentially is just a wrapper for the provisioning rules and the device profile, and then the device service that's supposed to be looking for these types of devices. So it's a pretty simple thing here, but this allows you to set, let's say you want to add any Bluetooth device that has a certain name, a certain MAC space, and it's able to be, you've got some rules about, okay, it has to be able to respond to these commands in a certain way. You've got to have some authentication. You can define all those things at the device service level in order to set rules about what you're adding to your system. So that's about it for today on the presentation side. I'm sure I know Brett had asked us to wrap a little bit early to get over to the TSC call, but we left plenty of time for Q&A. This week's call was at 9 a.m. Eastern. Next week will be at 6 p.m. And so some future topics for this talk. We've got core command on the slate. We've got console and the config registry microservice. So this is talking about service discovery and service registry. And then we've got the device service SDK as well. And then we're open to other suggestions about areas you guys have questions. As always, we're available on Rocket Chat and through email, through the mailing list. All right, so let's flip over to some Q&A. Oh, before we start that, I do want to address, I had seen one question last week, if Michael Hathaway is on the line, about API keys with regard to devices. So our device object inherits from the addressable class as well. And we do have a username and password field there. If you're looking to add API keys, I would start there. But we do have some provisions built in for that. It's just going to be handled, the actual API key handshake is going to be handled by the device service.
Yeah, I'm here, Tyler.
Great.
Will you provide an API key to talk to a remote device, or are there provisions? Because right now we have a system where the device can issue a key and provide its IP address, and then the intent was then that could be put in a directory for something like EdgeX to discover the device.
Yeah, absolutely.
So you support
right now,
that?
yeah.
Okay. And is EdgeX going to be issuing keys as well? And is there a way for say an application to say I want to register or get permission to talk to this device? Are you providing a directory of access information to devices in the metadata stream for that?
As far as application permissions on who gets to speak to which device?
Exactly, yes.
Right. So right now, I don't think that's built in. There's nothing in the system that would prevent that type of multi-tenant support, though. Okay. That'll go through the security working group.
Well, we should talk, because we can contribute some things there. We've been doing this for about 6-7 years, so we've got lots of stuff. So maybe we can have an offline discussion, because we're prepared to contribute some software in that area. But this is excellent. This is definitely, finally, thank God, people are moving in the right direction. We like it. Appreciate it.
Thanks. All right.
Hey, Tyler.
Yes.
This is Salim.
Hi.
Thank you. A quick question. So when a new device is added, if you have export services that are interested in being notified,
right,
how does that work? And are you going to cover this in some future topic? Or
no, absolutely. So I'd be remiss. So what we have is we have a notification service, which metadata, when it's issuing, I'd mentioned the callback earlier to the devices. It's a device service when it gets added. So right here. So what actually is happening there is we've got the notification service allows for other endpoints to subscribe to different types of callbacks here, in which case you can have your application or export service register to the notification service, and that looks for these different alerts about devices being added, devices being changed, devices being removed, and so that's all through that. So you can kind of think of that as an export service for these notifications.
Cool.
That makes sense? So the notification service, you can check out the APIs on that.
Okay.
Okay.
Perfect. And another question just came through the chat, Tyler.
Okay.
For bottom-up approach, could it be controlled if a device is discovered and added in a certain state, say disabled, so that operator can make the final decision for activating the new devices?
Absolutely. So yes, you can initialize device and add it to the system with yes, operating state disabled. That's absolutely correct. And you can also have some initialization commands issued to the device if you need to do any one-time initialization things. So let's say I need to flip it over to reading or to outputting in Celsius at the device level when it comes on board, because I don't want to do that during the transformation. You can have that mode setting during the initialization stage. And that's for a bottom-down or bottom-up or top-down approach. Okay. Any other questions?
quick reminder, if anyone is trying to speak up, the lines are auto-muted when you join. If you're having issues coming off mute, just leverage the chat window in the bottom toolbar of your Zoom, or worst case, send an email to info@edgex. We'll relay these over. But as Tyler mentioned, both him and Jim pretty active on the Rocket chat, so that remains a great resource to leverage. A question just came across, Tyler.
Yes.
About bootstrapping. Can a new device fill in the metadata about its family devices before it registers itself?
Okay, so let's see. So this would be the device providing its own profile type of thing, or is this about more of mesh networking where it's providing, where you have one entry point and then it kind of fans out from there? So what I will say is you can build your device. Let's see. Okay. So in a generic protocol sense, no. But if you build your own device service, you're welcome to do whatever you'd like there. As far as initializing other brands, types, revisions of devices, you're certainly welcome to build in things like that.
Perfect.
Questions? I'm sorry.
Just wondering how and from where does all this metadata specifics come from?
Right. So what we have right now is the device profile is going to be written by hopefully the device manufacturer. If not, then the development community can say, hey, I want to use this device. I'm going to contribute this profile. We've got a bunch that we've worked with in-house here. For example, Bosch XCK and TI sensor tag. We've got KMC thermostats. We've got a whole bunch of different things. Once you've written one, they become a lot easier to write. And then, yeah, but the profile does have to be written as a YAML file. No problem. Any other questions? All right, well, I'll give you guys a little bit of a break before the TSC call. Brett, what time is that supposed to start?
It starts in 30 minutes, so
all right.
thank you.
Yeah, thank you guys
for guiding us this morning, Tyler.
Absolutely.